Hello everyone. This time I'm back with a question from section 15.3, question 17, which asks to use double integral to find the area of the region inside the circle given by this equation and outside the circle given by that equation. Okay, let's just quickly review how we use double integral to find the area of a region. So area of region, any region D, is equal, if you want to use double integral, what you need to do is just double integral over D. It is easy. Just 1 dA. The integrand should be 1 when you're trying to find the area. In this specific case, we have to see what is that region. First, describe it, at least sketch it first, then use the double integral to find the area. So, x minus 1 squared plus y squared equals to 1. This is equation for circle, so it is circle, centered at the components of the center. For x is 1, for y is 0. And radius, the radius squared is 1, so then radius is 1. What about this other guy, x squared plus y squared equals to 1? This is the famous one. The circle, unit circle centered at 0, 0. There is no number subtracted from x and no number subtracted from y, or the number is 0. Radius is squared is 1, so then that means radius is 1. So if I try to draw the graph of that region, so this one, the center is 1, 0. The radius is 1, so I will touch the origin, and that's the 1. And this other circle centered at 1 and it touches 1, 0. Okay, then the region that we are trying to integrate is outside x squared plus y squared equals to 1, which is this part, and then inside x minus 1 squared plus y squared equals to 1. So it is this thing, the whole thing. But okay, now we have this region. We have to describe it in a coordinate and change this double integral to an iterated integral and evaluate that integral. So here is where we have to choose the right coordinate. First sign to choose the coordinate is all the parts of the region are circle. So we are better to go with polar coordinate. You can try Cartesian coordinate, but you have to do at least 3 integral to evaluate that integral in the Cartesian coordinate. So let's do the polar coordinate. So I have to write these guys in polar coordinate. In polar coordinate, this is nothing but r squared equals to 1. So in polar coordinate, let me write it in blue. This guy, equation of this guy is easy. What about the other one? So x minus 1 squared plus y squared equals to 1. So I can write r cosine theta minus 1 squared plus r sine theta squared equals to 1. Simplify everything. So you get r squared cosine squared t minus 2r cosine theta plus 1 plus r squared sine squared theta equals to 1. This one cancels with that. R squared sine theta, r squared cosine theta will give us r squared minus 2r cosine theta is equal to 0. That R is always non-zero, so you can cancel this R with that R, so R is equal to 2 cosine theta. So the equation for the circle is now R equals to 2 cosine theta. Okay, now if I want to write my region outside this, inside that, in polar coordinate, the D is all R thetas. I can see that the variable R goes from this, which is 1, to that. So R is going to be from 1 to 2 cosine theta. What about theta? So you start from this point and just come up and just that point. So this would be 1, this would be other one. So this would be alpha, this would be beta for boundaries. But what are those things? So you have to intersect these two circles to find that. So these two circles are given by this, so intersection. So intersection. R equals to 1, R equals to 1, and R equals to 2 cosine theta. So the cosine theta would be half. What are the angles whose cosine is half? So you know that theta could be pi over 3, and it's negative. So this is negative pi over 3, this is pi over 3. So my theta for this region would go from negative pi over 3 to pi over 3. Okay? Now I have full description of my region. Let me erase this part and then go from there. So then the area of the region, area of D is, I want to write this integral in polar coordinate. First thing is go from negative pi over 3 to pi over 3. Go from 1 to 2 cosine theta. And then 1 is here, so 1 is there. I don't. dA in polar coordinate is R dr d theta. I don't need to put that. Now my integral is written in as an iterated integral in polar coordinates. Now I can integrate that. Okay, this is negative pi over 3, pi over 3. This is R. Antiderivative of R with respect to R is half of R squared, and we go from 1 to 2 cosine theta d theta, and then pi. So plug in these guys there. So it is going to 4 cosine over 2 cosine squared theta minus, and you plug in there 1, you get half d theta. Okay, so I have now this easy regular integral, just one integral. So here I have to use a half angle formula. So cosine square theta is going to be 1 plus cosine 2 theta over 2. Yes. So now I can plug in there as pi over 3, pi over 3. Multiply by 2, it is 1 plus cosine 2 theta minus half d theta. Okay, these two cancels. I have cosine 2 theta. What is antiderivative of cosine 2 theta? If it was cosine theta, it would be sine theta, but now it is 2, so I have to multiply by half, so that I get rid of that 2. 1 minus theta, 1 minus half, it is plus half. That's half theta. I have half here, antiderivative of that is half theta. You go from negative pi over 3 to pi over 3. Okay, then let's plug in these guys in. So half of sine 2 pi over 3 plus half of pi over 3 minus half of sine negative 2 pi over 3 minus half of pi over 3. So plus, that's okay, pi over 3, the sine of pi over 3 is root 3 over 2. 2 pi over 3 has the same thing, so I have half times root 3 over 2 plus pi over 6 minus. This minus signs comes out, so I can multiply this minus in. I have this. This is half of root 3 over 2. And again, this minus comes out. You multiply by that, you get plus pi over 6. You can now simplify these things. You get root 3 over 2, if I add these two, plus, if I add these two, you get pi over 3. Okay, very quick wrap up. I know that if I have a region, I can get the area of that region by this double integral. But as we saw, the region that we had in this case was circular, so that would be, in that case, that going to the polar coordinate would be the right thing to do. So I did go to the polar coordinate, find the boundaries, do iterated integrals, and find the area of that region. Thank you for watching video. Have a great day.